Hi, my name's Iain Weir. That's me impersonating a vicar, which is the profession my mother wanted me to follow, but I disappointed her as I'm a lecturer in statistics at UWE. In 2014, I became part of the Dewis development team at UWE, headed by Rhys Quinthew and Karen Henderson, who I view as the Dewis dynamic duo. My role has been to run the statistics side of Dewis e-assessment. In this talk, I will tell you about some of the innovations in the e-testing of statistics for non-specialists that we have been responsible for. I am going to report on our experience of running a first-year module that is taken by over 400 business students at UWE. The module, which ran for the first time in the 2017-18 academic year, comprises a single semester course covering a challenging amount of material together with learning the use of SPSS. The students are non-specialists in statistics, with many of them last encountering any form of maths at GCSE level. The topics covered comprise the bread and butter of elementary statistical analysis. It is important that students gain sufficient competency and understanding of the techniques so that they are able to perform data analysis when collecting their own primary data in their Level 2 research project the following year. The following are some of the challenges that have been overcome by the use of e-testing on this module. How to teach the students so that they are able to self-learn SPSS. How to get the students to attain required statistical competency and understanding. How to support students to be capable of formal report writing. How to efficiently assess the large number of students. How to monitor student progress in a large cohort and to target those that are struggling. Students get 3 contact hours per week for the module. This breaks down to a lecture and supporting computer lab delivered by statistics staff and a tutorial from business school staff to supply relevant context to stats topics taught. Okay, so let's have a look at what the module assessment looks like. Well, the controlled conditions element is provided by the statistics staff. This needs to concern statistical knowledge, SPSS use, test choice, interpretation of output, formal report writing. The final mark is the average of the best 2 from 3 in-class tests that are spread out through the semester. In each e-test, a student receives their own unique dataset to work on and performs a complete statistical analysis of it using SPSS. The uncontrolled conditions element is set by the business school. The students have to do a 1,200-word report that comprises the statistical analysis of a supplied dataset in response to a business question. The dataset has many variables, and the students decide something of interest that they choose to analyse and report on. This work is carried out at the end of the semester, i.e. after all of the statistics teaching. Online statistics support for potential dataset-specific problems is provided. This very much is akin to giving supervision advice and may encompass issues that haven't been covered by the formal lectures, for example, dealing with low counts in a nominal variable. The assessments are called Dewis R e-assessments, where Dewis supplies the administration of the assessment, but the statistical computations are performed by R. Dewis is a fully algorithmic open source e-assessment system which was designed and developed at UE in 2007. There is a Dewis R interface to allow creation of e-assessments using R script. The diagram gives a pictorial representation of the setup. The student is sitting at a computer terminal and through Blackboard logs on to the Dewis system. When the student starts an assessment, Dewis runs R code which creates data. This then gets passed back to the student. The student puts the data into SPSS and gets output to answer various questions. The student then engages with the e-assessment system, and when submits the answers, Dewis again runs some R code which provides the correct answers, and then Dewis provides the marks back to the student. Dewis Key Skill e-assessments are the main learning tool which have a narrow focus on mastering one specific statistical technique. These are designed to encompass the range of possible statistical outcomes, for instance significant or non-significant test outcomes. We encourage the students to have repeated use of these until they've mastered the technique and are comfortable with the various possible outcomes. Let us now consider an example of the Dewis Key Skill E-assessment. This E-assessment concerns using a 95% confidence interval for the mean to infer about a change to a hypothesised population value. The student is told that the IQ in the general population is 100 and that the box plot is the IQs of a random sample of people taking a certain medication. The student is asked if the 95% confidence interval for the mean indicates that the medication is affecting IQ. Note that having a graphic in the question allows immediate curiosity and for the gaining of a gut feel for the impending analysis. This is really useful when trying to encourage a student in a computer lab and reinforces the student's understanding of box plots. For instance, with this randomly generated data, I would explain that the median appears to be lower in the high 80s and that from the upper quartile we can see that around 75% of the people in the sample have an IQ less than 100. It thus does appear that whilst on this medication IQ may well be lowered. I would point out that the second person in the dataset is a mild outlier who appears to have a rather high IQ, and that in a real analysis the least we should do is to check it is a genuine observation. In more advanced questions which involve test assumptions, I would also use these box plots to talk about symmetry, skewness and normality. I am always saying to the students that the box plot would be my desert island statistic if I was only allowed one. There is a download link to supply the data in a CSV file. The student has to transfer this into SPSS. Each Key Skill E-assessment has multiple embedded links to comprehensive help pages that provide SPSS how-to information or output interpretation. This form of support is more targeted and immediate than a student having to refer back to the notes. It allows students to work independently and at their own pace whilst also freeing up staff to concentrate on giving higher level interpretive advice. For instance, this one gives the SPSS instructions to import the CSV file. Once the data is in SPSS, there is a data transfer check that involves checking the standard error of the mean. There is a help page that explains the student needs to use the explore command to get the necessary output. Here it looks like I have transferred my data OK. When a student complains about getting wrong answers despite doing what is asked, this is the first point of call for the staff to usually diagnose that they have been in fact working on the wrong or a corrupted dataset. Note there is information on the accuracy to report results. For instance, here it is to report what they see on the screen, having successfully transferred their data to SPSS. If we now consider answering the questions, we note that the E-assessments give practice in the formal writing of statistics. So, filling in some answers, I see that the sample had 20 people in it with a mean IQ of 92.30. The lower 95% confidence limit is 85.97, so these three are correct answers. I won't answer the upper 95% confidence limit. As for the inference, we can see from the SPSS output that 100 is not contained within the confidence interval, thus the medication does appear to be affecting IQ in a detrimental way. However, I shall select the incorrect answer that the mean IQ appears to be higher. Note that there is a button to reveal the marking scheme, which here is 1 mark for a correct answer and no marks otherwise. OK, let's submit. The students get an initial report which briefly summarises the student's attempt and provides the E-assessment percentage score. The solutions section of the feedback supplies the correct answers that the student needed to complete. A pictorial representation of the confidence interval is included, along with accompanying text in blue that provides extra feedback information with the aim of aiding students' understanding of the correct inference to the question posed. The report section indicates with colour-coded marking what the student has answered correctly in green or incorrectly in red. It can be seen that the student has one wrong answer and a not answered input. Robin is currently working on identifying any such Dewis accessibility issues, whilst Blackman is working on a solution that will automatically add ticks and crosses and will display messages when hovered over in a browser. I told you they were a dynamic duo. The students are encouraged to retry each Key Skills e-assessment until they've mastered it. By repeating them, they'll experience various analysis outcomes which will prepare them for the future. For instance, in this run, it is not clear whether there has been a significant change in IQ. This indeed is confirmed by performing the formal analysis. Through the Dewis management system, staff can view the marks and feedback of each and every student attempt. This is useful to ascertain and subsequently address common misunderstandings amongst a cohort. The student at a later date can return to the feedback pages of any previous attempts, which is useful when seeking further clarification of understanding at a convenient mutual times that suit both them and the staff. We have created a web resource whose link is on the conference Moodle site. This focuses on the student learning journey up to the first in-class test, which they sit in week 5. You can view week-by-week information on the teaching and learning activities in the lecture and computer labs. Each week's Key Skill e-assessments are listed, along with their rationale and design features, and you can click on the Try Me buttons and have a go yourself. In week 2, a supplementary teaching activity is introduced, which are pre-written analysis templates. Students are required to populate these with SPSS output, numerical values and interpretation decisions. This allows students to practice importing output into Word, and when completed give them a portfolio of analysis reports to refer to in later student life. Week 3 has the most Key Skill e-assessments. In total there are 11 that get them ready for the in-class test in week 5. You can try the first in-class test and see how this combines the key skills learnt to enable the students to perform a data-dependent analysis involving either the one sample t-test or its non-parametric equivalent, the Wilcoxon signed rank test. We shall have a quick look at the in-class tests, which will give you an idea of its complexity, and I'll highlight some other features not seen in the key skill example. The question concerns a supplier of bottled mineral water who claims that his supplied water has an average sodium content of 37.0 milligrams per litre. Note that the null hypothesised average is random each time the test is accessed. There is a box plot of the sodium content levels taken from a random sample of 15 bottles. Note that data of random sample size is supplied each time the test is accessed. We have been asked to investigate the supplier's claim using SPSS to apply the appropriate test. Note that data is randomly generated so that with equal chance students would experience both tests and significant or non-significant results. The students need to do some exploratory data analysis, which includes looking at the 95% confidence interval for the mean to see whether the supplier's claim is plausible, i.e. utilise the key skill that we have already looked at. The student also looks at skewness and performs a normality test, which together with the sample size will inform the student which main test to perform. The main test is chosen using guidelines that the student has been taught that considered sample size, skewness and normality. The student has to choose between the one sample t-test and the Wilcoxon signed rank test. Only one test can be chosen. The student is reminded of the test choice decision rules, and the marking scheme is available, and this shows that correct selection of the main test is worth 3 marks. There is follow-on marking if a student makes a wrong test choice. If the student chooses the one sample t-test, then these inputs need to be entered. If the student chooses the Wilcoxon signed rank test, then these inputs have to be entered. The feedback solution shows a complete analysis with a defendable test choice. Note that there is extra feedback available to explain the correct test choice. The first in-class test has 22 inputs with 1 mark each, plus there are 3 marks available for the correct test choice. If students make the wrong test choice, then follow-on marks are carried out for the test that they performed. The second in-class test involves comparing 2 population averages. Students need to check test assumptions to decide which of 3 possible tests to report. The third in-class test concerns correlation or regression. We should now consider some of the mechanics for delivery of each of the in-class tests. Students had unlimited attempts to a practice test a week before the in-class test. Practice test is exactly the same as the in-class test that they would sit, except of course every time they practice it, different data will be generated, and hence different outcomes encountered. The test ran in the same session and room as the student's timetabled PC session. Each session was scheduled for 50 minutes, and the time limit for the in-class e-test was 30 minutes. Thus, with up to 50% extra time for reasonable adjustments, we were able to carry things out within the scheduled time. The in-class test link was protected by an examination key, and this was different for each PC group. So what were the e-test results like? The fieldboard reports indicated that there were 52 non-active students, and thus in the following I consider just the 365 active students. 94.5% of students took the first e-test, and the majority of these did very well. It was reassuring to see that there was a fair percentage of students who were capable of a perfect analysis. The second e-test was taken by less students, and the results were more spread out. Again, there was a fair percentage with high scores. The decline in the number of students attempting the third e-exam is due to the final mark for the in-class test component of assessment being the best 2 from 3. Many students with high marks from the first 2 tests elected to not take the final test. The lower mean mark for this test reflects this as well. Based upon the best 2 from the 3 e-tests, 88% of active students passed this element of the module. 115 students did all 3 tests, and 2 students got 100% in all 3 tests. I personally contacted the pair of them to congratulate them on this achievement. It is of interest to see how students prepare for each of the e-tests. Many students made multiple attempts at the practice tests. For the first e-test, the median number was 5 attempts. There were a few students who appeared to get addicted to the practice tests, the worst case being a student who had 96 practice attempts. I must admit I was a bit disappointed that this student didn't go for a 3-figure score, but the good news is that the student achieved 100% when they set the actual exam. The second e-test has the same median number of attempts. The third e-test had a lower median number of attempts and less OCD behaviour. Of those that sat each e-test, approximately half had previously tried the practice tests. I find this a surprisingly low amount. Those that did practice experienced a significant uplift in average marks compared to those that did not practice. Here we see that the uplift is not just significant, it's also substantial. Note to students. There was a high number of students who have viewed their feedback. For the first 2 e-tests there was a figure of just over 80% of students that viewed the feedback. However, this dropped to 54% for the third test. Again, the drop in test 3 is probably understandable if some of the better students elected to not take this test. However, a little Robin has told me that this is much higher than the 10% that is typical for paper-based work. A similar module was run in semester 2, and it had its last 3 delivery weeks under lockdown. So how did this affect things? Fortunately, I had recorded the semester 1 lectures, so these got recycled. The computer labs became virtual through Blackboard Collaborate. Students were told to engage with the materials as normal and to stick their hands up in Collaborate when they wanted to talk to one of us. The students would then be moved into a private breakaway room where we answered their queries. Effectively, this is very similar to what would have happened in the computer lab. We held these at the same scheduled times as we knew the students were free, and felt that maintaining a routine was a good thing to do. The third e-test became a remote one. They were held at the same timetabled times, with a half-hour window to start the test, and Dewis only allowing submissions within designated times, i.e. including extra time for those with reasonable adjustments. The transition to lockdown was thus not onerous. The following are some of our thoughts about the teaching approach that's just been described to you. We believe that students have a solid foundation in using SPSS to perform standard statistical tests. They will experience further material in the second year and will then use the techniques learnt to analyse real data in a substantial research project. The e-testing regime and continued access to the comprehensive learning materials will facilitate their transition to becoming independent researchers. E-testing was found to be suitable for life under COVID-19 lockdown conditions.